into 4. So you get 4 plus 6 minus 8, isn't it? Which is 2, isn't it? The following equations were obtained in a research project. 1 over x plus 2 over y plus 2 over z is equals to 4. Then equation 2, 3 over x minus 1 over y plus 4 over z is equals to 25. And the third equation, 3 over x plus 2 over y minus 1 over z is equals to negative 4. Use the elimination method to find the value of x, y, and z. Are we together? You've been told to use elimination method. So to use elimination method to solve this kind of problems, you start with the first equation. So in the first equation, we have 1 over x. 1 over x is the same as 1 into 1 over x, then plus 2 over y is the same as 2 into 1 over y, then plus 2 over z is the same as 2 into 1 over z to be equals to 4. Are you together there? Then you go to the second equation, 3 over x is the same as 3 into 1 over x, then 1 over minus 1 over y is the same as 1 into 1 over y, then plus 4 over z is the same as 4 into 1 over z to be equals to 25. Then you move to the third equation, 3 over x is the same as 3 into 1 over x, then 2 plus 2 over y is 2 into 1 over y, then minus 1 over z is 1 into 1 over z to be equals to negative 4. So the thing you say, you let x1 to be 1 over x, or you say you let 1 over x to be x1, isn't it? And you let 1 over y to be y1, and you let 1 over z to be z1. So it means the moment you found the values of x1, y1, and z1, then you can now get the values of 1 over x, 1 over y, 1 over z. If you use them like that in that equation, you'll only be complicating it, isn't it? So it means in the first equation we are going to have 1x1 plus 2y1 plus 2z1 is equals to 4. Then in the second equation we have 3x1 minus 1y1 plus 4z1 is equals to 25, isn't it? Then in the third equation we are going to have 3x1 plus 2y1 minus z1 is equals to negative 4. So for you to use the method of elimination, this is what you do. You use the first two equations, you put that is equation 1, then the last two equations to form equation 2. Are we together? So you come and now state in the next line, I have 1x1 plus 2y1 plus 2z1 to be equals to 4, and 3x1 minus 1y1 plus 4z1 is equals to 25. So what you do, you want to eliminate the first variable, which is x1. Are we together? What you do is to interchange the coefficients of x1. The coefficient of x1 in the upper equation is 1, meaning you multiply the down equation by. The coefficient of x1 in the down equation is 3, meaning you multiply the upper equation by 3, isn't it? So we now have 3 times 1 is 3x1 plus 3 times 2 is 6y1 plus 3 times 2 is 6z1, then 3 times 4 is 12, isn't it? Then here 1 times anything is just, it remains the way it is, isn't it? So that is 3x1 minus 1y1 plus 4z1 is equals to 25. Then we subtract the two equations to eliminate x1, isn't it? Are we together? So if you subtract the two equations, 3x1 minus 3x1 is 0. So 6y1 minus negative 1y1, that means it is 6 plus 1, isn't it? So you have 7y, y1. Then you go to the next, plus 6z1 minus plus 4z1, that is 6 minus 4, which is plus 2z1, isn't it? Then 12 minus 25, negative 13. So you make that one now becomes equation 3. Are we together? Then you go to the last two equations, which is 3x1 1y1 plus 4z1 is equals to 25, and 3x1 plus 2y1 minus z1 is equals to negative. So you multiply the up equation with the coefficient of the other equation and the down equation with the coefficient of the other equation. X1 is what we are eliminating, isn't it? But you see, they have the same coefficient, so it means there is no need of doing that, isn't it? Because that method only applies when the coefficients of the variable you are eliminating are different, isn't it? But here they are the same, so we don't do any multiplication. Are we together? We just subtract the two equations to eliminate x. 3x1 minus 3x1 is 0, isn't it? I am negative 1 minus positive 2, that is like negative 1 minus 2, isn't it? So you get negative 3y1, isn't it? Yes. Then positive 4 minus negative 1, that is like 4 plus 1. So you get 5 plus 5z to be equals to 25 minus negative 4, that is 25 plus 4, isn't it? 29. So that one becomes equation 4. So we now use equation 3 and 4 to eliminate y1 so that we get z1, isn't it? So equation 3 we had 7y1 plus 2z1 is equals to negative 13, isn't it? Then equation 4 we have minus 3y1 plus 5z1 to be equals to 29, isn't it? So the coefficient of y1 in the up equation is 7, meaning we multiply the down equation by 7, isn't it? The coefficient of y1 in the down equation is negative 3, we multiply the up equation by negative. So start multiplying negative 3 times 7 minus 21y1, negative 3 times positive 2 is negative 6z1 to be equals to negative 3 times negative 30, positive 39, isn't it? Are we together there? Then go to the down one, 7 times negative 3 is negative 21y1, isn't it? 7 times positive 5 is plus 35z to be equals to 7 times 29, 203. Then we subtract the two equations to eliminate y, isn't it? Negative 21y1 minus negative 21y1 is 0, isn't it? Then you go minus 6 minus plus 35, that is like minus 6 minus 35, isn't it? You get negative 41. Z1, isn't it? Then 39 minus 203, negative 164. Negative 164, isn't it? So for you to get Z1, you divide both sides by negative 41. So you divide both sides of the equation by negative 41. So you will get Z1 is equals to Z1 is equals to 4. Are we together? Having found Z1, you use either equation 3 or 4 to get y1, isn't it? Are we clear there? So here we have, if we use equation 3, 7y1 plus 2z1 is equals to negative 13. So it means 7y1 is equals to negative 13 minus 2z1. If you take plus 2z1 on the other side of the equation, isn't it? Then you substitute the value of z1, what do you have? 7y1 is negative 13 minus 2 times 4. What do you get? You get 7y1 is negative 20, negative 21, isn't it? So you divide both sides by 7 to get y1. So what is y1? Negative 3, isn't it? So y1 is negative 3. So having found z1 and y1, you use either any of the equations in the initial problem, isn't it? To get x1, isn't it? So if we use the first equation, which appears more simple, that is x1 plus 2y1 plus 2z1 to be equals to 4. So it means x1 is 4 minus 2y1 minus 2z1, isn't it? If you take plus 2y1 on the other side of the equation, it becomes negative, isn't it? If you take 2z1 on the other side of the equation, it becomes negative 2z1, isn't it? So start substituting. x1 is 4 minus 2 times y1. That is minus 2 into negative 3, isn't it? Then minus 2 into 4. So you get 4 plus 6 minus 8, isn't it? Which is 2, isn't it? Which is 2. So far, we found x1 to be 2, and we found y1 to be negative 3, and we found z1 to be 4. So what was x1? x1 was 1 over x, so it means 1 over x is 2. So that implies x is 1 over 2. The reciprocal, you look for the reciprocal on both sides, isn't it? Yes. If 1 over x is 2, is the same as 2 over 1. So if you look the reciprocal on both sides of the equation, you get x is 1 over 2. Are we together? Yes. Then you move to the next one. Y1 was 1 over y. So it means 1 over y is negative 3. So that implies y is negative 1 over 3. Very simple from both sides of the equation, isn't it? Yes. Then you move to the next. Z1 was 1 over z. So it means 1 over z is equals to 4, all 4 over 1. So if you look for the reciprocal on both sides of the equation, you get z is 1 over 4. And you solve the problem. So that is how to solve a system of simultaneous equations of that nature. Okay? It is very, very common case. It's a very common case.